First snow of the season. Really nice. Having a nap. Hi everybody, and welcome to the next episode of Watch Tony Suffer. Not really, this is not too bad. Here's where we are. I want to do a little demo here of what an amplifier does when it starts to go into what's called red plating. I know a lot of you that work with vacuum tube amplifiers have heard the term red plate, and what that really means is when the output tubes start drawing excessive current because of a problem in the amplifier, the plates of the tubes, or the anodes of those vacuum tubes, will heat up. They'll get very hot and they'll start to glow like an orangish red color. And of course, it's not going to be too long when you start doing that it will eventually cause the tube to fail. So checking a red plating tube can sometimes be a little bit of a challenge. Sometimes it's easy, but in circuits like this, sometimes it can be a challenge because unless you apply full power to the amplifier, you can't always get the thing to fail, depending on the type of problem that's in the amplifier. So I have an example of that right now. I have the electronic circuit breaker turned on right now and powered up. I'm looking at the bias voltage on one of the 7189s, or the 6P14s, whatever you want to call it. And it should be about minus 10 volts under proper operating conditions. As you can see right now, it's negative 1.8, so it should be higher than that. But the reason it's that way is because if you look over here, clear at the end of the screen, you can see that I have this set to limit. So what's actually happening is, I don't know if you can see if I tip this forward without destroying everything, but you can see that the dim bulb is in the circuit right now, and it is limiting the current. So because we're limiting the current, the tubes are not red plating, and our bias is not what the schematic says, so it's kind of hard to troubleshoot where the problem is. Now if we move over to the other channel and we look at that same area, you can see the bias voltage is about double. So several things can cause that, not the least being a faulty coupling capacitor. But because remember, we didn't change those, but we really want to see what this thing does when it fails. So let me show you how all this works. And I have the circuit breaker set to protect us against a red plating tube. So if I shut this off of limit, you're going to see the current and everything is going to start going up. This is going to change, and then all of a sudden it's going to do a nosedive. Everything's going to shut off. And you'll see the current right now, we're at 550 milliamps. It's going to drop. And yes, you can see I put a different meter in here because this one has better resolution. It, number one, can show us the wattage, but it also can show us the actual down to 10 milliamp resolution instead of 100 milliamp resolution what the old meter had. So anyway, let's flip this on, and it immediately trips. So let's reset it. And you can see this is going to climb up, and it's going to get closer to our 10 volts. There it is, negative 10. But now look at it drop. And all of a sudden, boom, this thing cuts off. So what you were seeing was as that tube was coming up to full power, it was starting to draw excessive current. And as soon as we went past the trip point that I set, which is about 1.5 amps, 1 amp, something like that, this shut it off real quick before anything got a chance to fail. So at least we're able to see kind of what's happening just before this thing trips. And I can set the trip point a little bit higher, which will run this, put a little more strain on the circuit. But for that little moment in time, we were able to apply full power without leaving it in there long enough to damage something. So you can see we have a few problems with the outputs. And if I remove these output tubes, so let's take them out. And as I said before, one side seems to get a little bit warmer than the other. And if you remember, one channel had a lot lower output than the other. So if we turn this back on now, it stays on and it's happy. I can turn this down now. And you'll see it'll just kind of sit there. You can see as this comes up. And again, you're kind of looking at an open circuit right now because there's no tube in the socket. But it's going to sit there and idle at about this 670 milliamps. Now, looking at my other voltages, for instance, this is your 380. And of course, I have to... It just tripped off. Hold on. Sometimes this... Oh boy. There we go. You can see it's floating very high now. It's sitting at about 423 volts. And the reason that it's sitting at 423 volts is because there's no load on it. It should be about, at that point right there where we're testing, should be somewhere, let's see, should be about 360 volts, which it will come down when you load it like that with those 4 tubes. But you can see nothing's drifting and nothing's loading the circuit down without those tubes. And I can go down here. This is going to be, and you notice when I put the probe on here, this circuit is so sensitive, it'll false trigger off of the meter. It's very sensitive to any kind of noise or anything. It'll trip. I need to make it a little less sensitive, but I haven't figured out how to do that yet. Some of it has to do with the circuits I'm using in there. But anyway, there's your grid, your screen grid voltage right there. And that's interesting too. Let me show you some interesting things about that. I hope you can see this okay. But if you look over here, first of all, we're using a GZ34 rectifier. And one of the things about a GZ34 is it has very low voltage drop. It only has about a 10 volt drop or so. They're actually showing a 40 volt drop from here to here, but that's AC there. So that's when it comes out of here, it's higher, but there's a low voltage drop on these compared to other rectifier tubes. And what they're trying to do here is compensate for that. If you notice, there's no capacitor on this side. So they're going through this 160 ohm resistor to drop off some more voltage to get it to the proper 360 that they want right there. So they're dropping a 20 volts across this 160 ohm resistor. And both here, in both of the schematics I have and in the parts list, they're listing this as a 2 watt resistor. But if you look right here, look how big that is. That's a 10 watt. And it is 160 ohms right on the button. And it looks, I can't tell if this is original, because I'll have to look at some of the, well, let's see, I have a picture of another one. Yeah. So you can see, even on some of the other ones I've seen, like here's a picture from the internet, they're still using that. So for whatever reason, after the schematic and parts list, they upped this from a 2 watt to a 10 watt resistor. Interesting stuff. If you look, here's your 2K resistor. This is the interesting part. This 290 volt source is your screen grids for your output tubes. And they're dropping it from that 360 volts down to 290 volts. And if you do the math and you look at that drop, this resistor right here, which is this one here, is dissipating about 2.5 watts, and it's a 5-watt resistor. So it's running, you know, under correct, when everything's right, it's dissipating about half of its rated wattage. But this is the really interesting one. They're putting a 15K resistor directly to ground here. And it's a 10 watt, and there it is. That's a big old resistor. And this thing's just dissipating 5.6 watts of heat. It's just, all it is just sitting there and burning hot so that you can have this 290 volts. And the only thing I can figure why they have this here is because your screen grid draws so little current, at least when it's working properly, that they couldn't get this regulated well enough. Now, of course, they could have put a larger resistor here, and that would have, you know, changed this voltage divider, but for some reason, they have this thing just doing crazy amounts of power, and this thing does get very hot. So this is a strange circuit, how they did this, and I really, if any of you know why you would do this, instead of having a different voltage divider and, you know, letting the screen grids handle the rest of it, I don't know. Maybe because this gives better regulation, I'm not sure. But the bottom line is, this is a crazy circuit that uses up an awful lot of power and just turns it into heat. It's not used by the circuit. Now, I know I'm jumping around here, but these are all the things that affect one another in this power supply. If you look, each amplifier, each channel, has its own AC balance and DC balance adjustment. But you only have one bias adjustment for both channels. So we could probably go through and measure all 4 of these to make sure, because it could be that the DC balance is off of one channel when I put those other tubes. Those are matched pairs of tubes, but nevertheless they have different properties than the 7189. Even though they're compatible, you still have to adjust the bias and everything different because the tubes work a little bit differently. So we could go through and adjust these. And I could just put the original 7189s in there, but I don't want to risk them if there's something wrong with this, because they're very expensive and they're very hard to find, the original good ones. So we're just going to do it this way. But anyway, you do not really have, if this side and this side are different, like if you have a different matched pair here from here, you can't really, there is no balance between the channels. There's only a balance between the individual tubes. So again, this is one setting for both channels. Okay, as you can see, all the capacitors have been replaced, at least in the amplifier section, in the preamp. And right there in the middle, you see that one little resistor. That is the only out of tolerance resistor so far that I've found in this whole amplifier. Isn't that amazing? That's the only one. All the other ones were good. So, bummer. I replaced the meter in this from that old one because it has a little better resolution. It was one I had and just laying around, but you can see the watt meter is not correct, and the reason being is if you push on the display, it shows up, but the display is bad, so I'm going to have to replace this again. But it just pops in, so it'll only take 5 minutes. I'll have to order a nicer one. But as you can see, it's idling nicely. This power supply schematic shows 117 volts at 175 watts. And you can see with the voltage drop in this thing and everything, I'm only running 113 volts. And I'm getting, and that equates to about 1.5 amps. And you can see we're right here at about 1.17 amps, which is really good. So The amp's idling nice. I have the bias turned the whole way down on the output tubes, so they're running very cool right now. But we're ready to give it another test and see if our one channel comes back. I also have one ground wire that came loose, and I'm not sure where it goes. It's right here. I'll have to find where that went. Eventually I'll get that fixed. But all in all, it cleaned up really nice, and you can see I kind of tidied up some of the wire, some more of the wires. Little by little it's cleaning up and looking really good. But everything is in good condition now, and yeah, we're going to have at least the amplifier is going to be working, it looks like. I hope I have everything in shot here. It's kind of tough to get everything at the right angle, but if you recall, when we first tested this out, and by the way, I have this off the leash now, it's directly plugged into the outlet and everything's working fine. Replacing all those capacitors down there helped out immensely, and I have the bias turned all the way down, so the outputs are not really set. They're not running very hard. We don't care about that right now. We want to find out why one channel is weaker than the others. So I have a 1 kilohertz signal being fed into the auxiliary inputs. I have the selector switch selected to auxiliary, and I have the stereo switch just set to normal stereo mode, because there's stereo and reverse and channel A and channel B and so forth. We're set to normal stereo. This is the volume pot down at the bottom. You can just barely see it. And here's your right and left channel inputs for the two sections of the pot. So if we look at this side, you can see I have a nice signal. And if I look over here, I have a much nicer signal, right? I actually have to turn this way down to even be able to see it. So there it is. And here's this one. See how weak it is? And that comes off of these two tubes here. So you have this one here and this one here. These are your tubes for your preamp section. And you can see the weak channel is there, and it's there. If we go over to here, there's our strong channel. So it's coming back to here. Now the inputs of those two tubes will be on pin 7 of each one of those, I believe. Make sure I'm saying this. Yes, pin 7. Pin 7 is going to be right here. And you can see I just about have a flat line there. And let's crank the sensitivity. So I do have something, but it's not very good. If I go up to this channel, all kinds of signal. Now looking at that, it goes back into, and yeah, I'm not going to zoom you in real well on this. I'm just going to hold it in front of you. But you can see it goes into your selector switches. And from there it goes to it bypasses the equalization section, you know, the phono stage, and goes straight to the signal input jacks, which are right here. See them? So we're plugged into the auxiliary, it goes through. So there's really nothing that we could be losing other than something on the switch. So now that you're kind of caught up to where I am, going in here, there's the connectors going in. Here's your wire. It's this shielded tubing here. And there's a green wire that you can just barely see back there. And this striped. And they come over, and here they are up here on the switch. And we have the green section and the blue section. And the blue, here it is. So if we look right up here, we should see some signal. And I don't know if you can see the scope, but there's your signal. Nice and strong. We go over to this pin, and there's really weak, almost nothing. And when we move around, look at that. Broken wire. Like I said, these wires are very brittle. You have to be very careful. And of course, this is where we were messing around, and you know my saying, show me where you've been and I'll show you where the problem is. So what we need to do is we need to take this little wire and strip it off and resolder it back onto the pin and see if our weak channel goes away. Okay, I'm sitting at an awkward angle, but we have the wire repaired, soldered back up there on the little pin. You can see it up there, maybe. Might be tiny. But we're back on our volume pot and look at the scope. Channel 1, channel 2. So I think we fixed our problem. It was just a broken wire, and that's a good thing. So now let's go back over to our amplifier here. I've not tried this yet, so I have no idea. Hopefully everything's good. I'll zoom you in and let's see if we get something. And again, I don't have bias or balance or anything set on these outputs, so heaven knows what's going to happen. But okay. We still have a weak channel if you look. I have the balance set and it is not going up equally, but there's still a few capacitors and so forth that I haven't changed, although that may not be the problem. We'll have to troubleshoot a little further, but the good, and part of it also could be that I have the bias set so low that we may just be seeing a problem with the tubes being biased so grossly low. But if we change our scale, we should be able to get this up, and there's your distortion. So just before, and there's your 16 watts per channel right there, roughly. Well, there it is, 9 watts. Crank it up. So, yeah. So and that's because the bias is way, way off. I have this bias, literally it's only allowing about half of the power of the amplifier, so it's not a fair test. So I'm going to go through and do a couple more tests, make sure this, I'm going to chase the signal the whole way through to the output tubes and make sure there's nothing wrong there, and then we'll see if we'll set our bias. Well, that was pretty easy. Let me zoom in here. So there's your volume pot, and this is the wiper that we're looking at. So here's the input. These are the two signals going in. We'll look at those in a minute. Here's the output, and I have the volume just turned up, and you'll see where I have it set. So this one here is set right up like that. So if you look, you can see the sine wave is touching the line. So we're going 3 divisions up and 2 divisions down. I don't have the sweep center. Don't worry about that. We have 1, 2, 3, 4, 5 divisions. Now, without touching the volume or anything, we're just going to move the scope probe to the other channel. And if we look at that, it's not even, what is it? 1, 2, about 3.5, something like that. So we already have a discrepancy in signal strength at the volume pot. So do we think that that's maybe the preamp section or the tone control section? Well, let's go back a stage and look at the input of this pot. So we're going to go here, and you can see it's way off scale. I'm going to turn it down, and you can see right here, if we line this up, sorry, you can see we just have a little bit over 1, 2, 3, 4, 5, 6 divisions. 1, 2, 3, 4, 5, 6, yeah. So just a little tip over 6 divisions. See that? Now, if I move to the other channel, I'll just hold it on there. It is ever so slightly less. So let me hook on somewhere where I can see it. And here's the other channel, 1, 2, 3, 4, 5, 6. Just a hair less. You notice on the other channel, if I make this touch the bottom line, it was kind of overhanging the top line just the tiniest little bit. So here's that channel, here's the other channel. Very close though, right? Move this on the line like we had it. You could see just that much more. That's really not enough signal that you should see much difference, okay, between that and that. But at the output, I'll go set this again. You can see it's a pretty big difference. So the question remains, is it the potentiometer or is it something connected to the potentiometer? So that's what we need to check. You notice there are some resistors down here and some other things, that switch network and so forth. So I need to check that and find out what it is. The good news is it's not our output tubes, and it's probably not our preamp tubes or anything like that. Power and everything is disconnected, and just statically checking across the wiper to this side of the pot, because I now have an absolute perfect input. It turned out to be the treble controls. Remember, this has individual right and left treble controls. They weren't perfectly lined up. They are now, and the signal going in was good on the scope. But if you look right now, I have the volume set, and there's 310K or 310,000 ohms on this channel. And if I move over to this channel, 340,000 or 338,000. So that's 28,000 ohms difference. And as I turn this up, you know, the resistance goes down. So for instance, we'll set this somewhere around 200K, like that. And if I go to this side, $22K difference or more. So there's a big difference between the two sides of this pot. So this volume pot's bad, and that's why the balance is off. Now, of course, we could compensate with the balance control, but that's not really the right way to do it. So we're going to possibly have to find a replacement volume pot for this, and that's not going to be the easiest thing on earth, I don't think, but maybe it will. We'll see. We'll see what we can find. Okay, folks, I did not get video of this, but I disassembled this whole volume pot, and I went over it and I cleaned all of the contacts inside. I checked the carbon track in there, the resistive material, and it's good. And the main problem between the two sides of the potentiometer, even after cleaning it and so forth, is if we look at the resistance of the first side, it's about 570 mega ohms, or kilo ohms, I'm sorry, about 560K. And this is a 500K pot. That's pretty normal for these. And if you look at the other one, it's about 573. So they're a little bit out of balance from one another now after a good cleaning. Let me make sure I get good contact here. They're 540 or so. So you can see this side here is lower resistance than this by about 30K. Now that doesn't sound like a whole lot, but when the volume is way down, that does make a big difference. So when you rotate it all the way counterclockwise, that means that the volume is turned all the way down. So that means the wiper, which is connected to this center tap here, the wiper is all the way over against this stop here. So that means these two are essentially shorted together or close to it. So how can we fix this? Well, you can replace these inserts, and I actually have some replacement inserts for these. The problem you're going to find is some of these, now I took this C-clip off and I was able to get this front section off. But the back section, the shaft is actually press fit. They actually have a press fit when you put these together. You can buy all the pieces and assemble these, but they're getting harder and harder to find. And it's press fit so tightly that I can take the switch off the back and I can take the front element off the front, but this middle one I can't get out. So to rebuild this, I would have to do that, which I don't want to risk damaging anything. And everything is in extremely good shape now that it's cleaned up, so I don't really want to ruin it. This switch cleaned up like brand new. I mean, literally, I polished it, and it looks brand new inside. I removed the pot, disassembled it as far as I could, cleaned it really well, checked it all out, cleaned the on-off switch, and reassembled everything. Now the main difference is the two elements between the two channels are slightly different. So one side is 573 kilo ohms, and it's supposed to be 500K. The other one is 543K, so 570K versus 543. So there's about a 30 kilo ohm difference between these two pots. And that's always going to give you a little bit of discrepancy. In other words, they creeped up a little bit. Now, the resistive element, the carbon tracks in there were very clean and very good. Everything was good. The wipers were absolutely perfect. There was no tarnish, anything like that. So I put it all back in and put it together. Now, replacing these wafers is a possibility, but you can't get this back one out because the shaft is press fit together. It's very hard to get apart. That front element I could replace. This back one you can't. So here's where we are right now. After cleaning it and adjusting it as best I could, I have the balance just a tiny bit off center. And you can see, here's our two channels. Well, it would help if I'd turn the right pot. And you can see just adjusting the balance a wee little bit. Just barely touching it there, and you can see it's tracking pretty good. There's clipping, and again the bias is way off on this thing, and it does go out here and there and then come back in. You can see that. That's just the property of these potentiometers. They're not precision. They never were. So you're just going to have to deal with things like that unless you want to upgrade to a different type of pot. But anyway, there it is. It's in there, and it works. So I think I'm going to leave Sleeping Dogs Lie with that. I think it's going to be good enough. And so ends another part in this series. So the next side, when we get to it, we have a few more things we have to do. On this side, we have a couple of capacitors to replace. Just a couple, shouldn't be too bad. And we're going to then focus on the outputs. We're going to go through the process of doing the biasing, the DC balance, and the AC balance adjustment, and see what kind of performance we can get out of the amplifier. The other thing we're going to do is we're going to replace these very hot resistors with some chassis mount ones. They'll run a lot cooler because they'll use this aluminum chassis as a heat sink and hopefully prevent this from getting so hot. That's where we are with this. So until next time, I wish you all peace, joy, happiness, and good health in your lives. We're coming along really well with this, and I'm starting to see progress that's kind of making me happy, and I think this is going to turn out to be a really good project. And we'll see what kind of amplifier performance we get on the next part of this series. And then the fun part comes, which will be the tuner. The AM and the FM, and then the multiplex. Looking forward to all of it. Take care, and we'll see you again real soon. And I have some things I'm going to show you that came in at the beginning of the next episode. We'll leave it a surprise. And that's it.